Hi friends, welcome back. Now, after looking at the working of RC phase shift oscillator, now it is time to look at the interesting concept of how tuned circuit can be used to produce a oscillator. Tuned circuit, as we discussed earlier, it's a parallel circuit L and C, and let us assume that when we started our experiment the capacitor was charged, and when we start our experiment the capacitor two plates are charged, means this plate has excess number of protons compared to electrons, and this plate has got excess number of electrons compared to number of protons, and hence both the plates are unstable. They are not under equilibrium condition. Equilibrium condition is one where number of protons, number of electrons should be equal. But they are not equal, therefore they are always striving to make that thing equal, and in that process the electrons start moving from here to here, and while moving they build magnetic field. So when there is movement of electron from this plate to this plate, they pass through the inductor, and this flow of electrons produces current, and the current will create a magnetic field. Because earlier there was no current, now there started a current, and the basic property of inductor is to oppose change in current. So earlier no current, now there is current, so it is opposing, and this opposition is seen as a magnetic field. This process continues. The excess electrons from here are pushed back to the other plate, so the imbalance on both the plates keeps reducing and reducing. Finally, at some time, they uh, become totally uncharged. That means both the plates are now electrically neutral, but by this time the inductor has stored its energy in the form of magnetic field, and it will not allow this flow of electrons to stop, and as long as there is a stored energy here, it will make the electrons to continue to move from this plate to this plate, and finally when the energy is done, the excess electrons have traveled from this plate to this plate, which means that now this plate has become negatively charged and this plate has become positively charged, and now there is no more energy in the inductor to make it flow. But the electric field is developed across the capacitor, which will not allow the system to remain in this, and hence now reverse current starts flowing from this plate to this plate, and this continues as long as these excess electrons are forwarded to this plate. So finally there comes one time when both plates again become electrically neutral, but by that time this has stored the magnetic field in the reverse direction, and that reverse direction will not allow this flow of electrons to cease, and it will make the flow to continue, and again we reach another stage where we had started. This plate gets again positively charged, this plate gets again negatively charged, and this process continues again and again and again. So if you just look at what exactly is happening if you just try to plot the voltage across the capacitor. So in the beginning we started with a maximum voltage, then it started reducing, and when it reached zero, that means the two plates were electrically neutral, but due to this magnetic field the charges continued to flow, and hence it reached the peak. When it reached the peak, the magnetic field is no more existing, but now we do have a negative electric field, and this negative electric field will make the reverse current to flow, and again it continues, and this continues on and on and on if there is no loss. But the circuit cannot be lossless because of a wire is used to create the inductance, and there can be a lossy dielectric in the capacitor, and because of which the output keeps decaying. It starts with full amplitude, and then with the time it reduces its magnitude. There is a decay in the output, and this decay, if somehow taken care, that is whatever energy is lost in this process, if it is added periodically, then we can expect continuous oscillations, sustained oscillations to take place. How that can be done? Yes, so after one cycle, if you assume that we make this connection on after a cycle, for a small period of time, if this switch is turned on, then there will be a current flowing here this way and making this capacitor to get the lost charge. So whatever charge it has lost during this cycle because of the lossy dielectric and loss in the wire of inductance, if that is introduced back, then we get a second round. We start getting this and then decayed. But here, if you can add again what is lost, if you can add what is lost here, then again it continues. So that way, it, after every cycle, whatever amount of energy is lost, if that energy is pumped in, then yes, we can expect sustained oscillations forever. So for this, what is required is this switching arrangement has to be taken care, and this can be done by a transistor circuit. We can use a transistor as a switch, and we need to turn on this transistor for a small period of time. Small period of time means definitely very much less than half cycle. So a class C type of amplifier is required here, and that small period of time is sufficient to refill the lost energy. Now the question is, how does the transistor know when to refill it? It has to be done in phase, in sync with the output. So it has to be exactly done at this point, and so on. So it has to be done in sync with the output, and without knowing what the output condition is, we cannot know when to turn on this one. So we need some feedback. So some feedback is required from the output side, and this feedback can be taken in two ways. One, you can connect this in the center of the inductor. That means use two inductors, so that gives you the idea of what phase is the output in. Or instead of working with one capacitor, you can work with two capacitors forming the third point, and that is taken for feedback. So depending on which component we use to produce this third point for giving feedback, we have two types of circuits. One, if you use the inductor point to create third point, then we get this circuit. Instead, if we use capacitor to create third point, then we get this circuit. So two inductors, a capacitor, this type of circuit is called Hartley circuit. So it is Hartley oscillator, and two capacitors and one inductor, it is called Colpitt's oscillator.